In the diagram, PQRS is a trapezium with the line QR parallel to the line PS, QR parallel to the line PS as indicated by these two arrows. Hey, look at the two arrows. And the U and the T are points on the line PS such that U, T are on this line PS, such that the length of P from P to U, the length is 5 centimeters as it is indicated in the drawing, and the Q to U, QU is 12 centimeters as also marked in the drawing, and the angle PUQ, this very angle is equals to angle STR, this very angle, so all are 90 degrees. And the question says if the area of the triangle PQR is 20 centimeters square, triangle PQR, this very triangle, its area is 20 centimeters square, this triangle. The question asks is to calculate correct to the nearest whole number D, question A, perimeter of the trapezium. So we have to find the perimeter of this trapezium PQRS. And question number B, we have to calculate correct to the nearest whole number in the area of the trapezium. So we have to find the area of the trapezium as well after getting the perimeter. So this is the trapezium. The perimeter is nothing but the total length of all the boundaries or all the sides of that trapezium, but none of the sides we know it is length. This is missing, this is missing, this is missing, this side is also missing. So we have to find the length of all the sides of that trapezium for us to be able to find the perimeter. So let's attempt to answer this question. Solution to this: so in attempt to get this perimeter, we have to get all the sides of the trapezium. That is our first task. This is 12, this is 5, and this triangle is a right angle triangle. So I can find the length PQ, because this triangle is a right angle triangle and PQ is one of the sides of the trapezium. So I can find it using Pythagoras theorem because the triangle here is a right angle triangle. So I can find the PQ using Pythagoras by simply 12 square plus 5 square, everything in square root. So 12 square is 144, 5 square is 25, adding 144 to 25 give us 169. Then I'll take square root of 169. That will be the length of the side PQ. Square root of 169 is going to be 13 centimeters. So the length PQ is now 13 centimeters. So this side is now known. So next, in the question it says area of triangle PQR is 20 centimeters square. Triangle PQR, this triangle, it is area in the question is 20 centimeters square. So let me attempt to get the area or to calculate the area of this, though is given, but that will enable me to get the base of the triangle. QR would now be the base of the triangle, and I will use 12 as it is height. Remember, formula of area of a triangle is half base times height. The base is now going to be QR, and it is height is going to be this 12, because it's simply when you extend this line over here, draw vertically down, it will be the same thing with this line QU12. So I'll continue. So I'm going to have a half times the base, which is the side QR, times the height, which is 12, but the area is given 20, so I'm going to replace that. I have 20 equals to 6 times the length QR. The 6 comes from this 1 over 2 times 12, simply 2 here 1, 2 here 6. So you have 6 times QR, the length QR times 1. So you have 20. 20 is the area given in the question. Area of the triangle, 20. I substituted it. Then this 6 is 2 into 12. It will be 6. So I continue to get the length QR, simply divide both sides by 6. The length of the line QR will now be 3.33 centimeters. So this side QR is now known. So I have two sides now, PQ and QR. Remember, I'm trying to answer this question number A, perimeter of the trapezium. So if I can get this and this, I'll be done. I'll continue. So next is to get the length RS, but we find that this side RT, or this height RT, will now be the something as the height QU. So this is going to be 12. So RT, the length RT is the same thing as the length QU, and the QU is 12 given in the question. So I have RT also what? 12. So if I continue, I'm now going to use this right angle triangle. This right angle triangle, I have this side 12, I have this angle 50, and this 50 is opposite to the side 12. I can get this using my trig ratio. So this is opposite, this is hypotenuse, so I'll take the sine ratio. So this is now going to be opposite over hypotenuse. So if I cross multiply to get the hypotenuse, it's going to give me RS equals to 12 over sine 50 degrees. Sine 50, like I have said, is 12 over RS. When you make RS subject of the formula, it's going to be RS equals to 12 divided by sine 50. So I continue. This is now going to be, after getting the value of sine 50 degrees from either calculator or for figure table and divide it by 12 or divide 12 by 8, the answer is going to be 15.66 centimeters. So this RS is now 15.66 centimeters. So what remains is this side now. I'll continue. So the TS from T to S is also a side in this triangle, right angle triangle. I can equally get this also using the trig ratio. This will now be adjacent and this will be opposite. So I can take the tangent ratio. So this, to get this TS, tangent, remember it says opposite over adjacent. So it's now going to be tan 50 equals to 12 over the length TS. When you make the length TS subject, is going to be 12 over tan 50. So we now find it the value of tan 50, divide 12 by 8. That will give the length TS as 10.07 centimeters. So this side is 10.7 centimeters. So what remains is the whole of S to P, or PS. This is 10.07. This is given in the question as 5, but U to T will now be the same thing as Q to R. So this is now 3.33 centimeters. So I continue to get the perimeter. So the perimeter will now be equals to, if I start from here, down here, down here, down here, I'll have the perimeter to be equals to 13 this side, plus 3.33 centimeters this side, plus 15.66 this side, plus 10.07 this side from here to here, then plus 3.33, which is T to U, this very side, because it's the same thing as this, then plus 5 this remaining side, which means these three values, 10.07 plus 3.33 plus 5, will now give the distance from P to S. So adding this correctly will give answer 50.393 centimeters, but the question says to the nearest whole number, so I have to approximate this to nearest whole number. That is going to be 50 centimeters. So the perimeter of the trapezium is now 50 centimeters. So question E has been answered. Question number B, it says area of the trapezium. Remember, area is given by the formula half into A plus B times height, where A and B are the parallel sides. So this is my 1/2. This will be my A, this will be my B, then this is my height. So the A is the length of this parallel side, 3.33 centimeters, while the B is the length of this parallel side from P to S, which we have 5 plus 3.33 plus 10.07, that will be 18.4, then times the height of the trapezium, which is this height. So continue, we now have 21.73 times 6. This 2 into 12 is 6, and 21.73 is the addition of 3.33 and 18.4. So multiplying this correctly will give answer 130 after approximating to the nearest whole number. So this will now be the area of the trapezium. So let's take the marking scheme for this very question according to the Waec marking scheme. The mark distribution is as follows. The first mark is the method mark, M1, where you are using the Pythagoras to get the length PQ. The next mark is the A1 mark. When you get the length of the PQ accurately as 13 centimeters, you have that A1 mark. The next mark is where you are using the area of a triangle in attempt to get the length QR. So substituting in that formula for area of a triangle, you have the method 1 mark. And when you get the length QR, meaning the base of the triangle, accurately as 3.33 centimeters, you have the A1 mark. Then the next is using the trig ratio in attempt to get the line RS, the length of the line RS, you have the method mark 1. And for getting RS accurately as 15.66 centimeters, you have the A1 mark. For using trig ratio also to find the length TS, you have method mark 1. And for getting that length accurately as 10.07 centimeters, you have the accuracy mark A1. So the next page, the next mark is M1 mark, the method mark, where you attempt to get the perimeter by adding all the sides you obtained. So adding those sides, you are attempting to get the perimeter, you have this method 1 mark. And adding them and get the answer as 50 centimeter approximated to the nearest whole number accurately, you have this A1 mark. And next is the area, attempting to get the area of the trapezium by substituting the A, the length of this parallel side and the length of this parallel side and the height, you have the method mark. And the final mark is when your answer is 130 centimeter approximately equals to the nearest whole number as 130, you have the A1 mark. So in total is 12 good marks.